Good afternoon, ladies and gentlemen. We're back again with another tutorial video. Now we'll be talking about ions. So our specific question is, what are ions? So let's go ahead and get started. Ions are elements that have a positive or negative charge as a result of gaining or losing one or more electrons. So let's look at our most famous example of ions, and let's go ahead and take a look at sodium and chlorine. Sodium has 11 protons and 12 neutrons in the nucleus of its atom. Since it has 11 protons, it's also going to have 11 electrons in an electrically neutral atom. So what we're going to do is we're going to draw our electrons, and we're going to put 2 on this first ring because we can only fit 2 on that first ring. And then on the second ring, we can fit up to 8. So I go ahead and draw my 8 valence electrons on this second ring. And then on this third ring, we can fit more, but we only need 1 valence electron out here. The reason why, because we have 11 protons here and we need 11 electrons. So 2 plus 8 gives us 10, and then plus this 1 more gives us 11 electrons. So now this atom is neutral because I have 11 protons, which are positive, and I have 11 electrons, which are negative, which gives us a total charge of 0. Now let's move over here to chlorine. Chlorine has 17 protons and 18 neutrons. Since it has 17 protons, it also needs 17 electrons. So now let's go ahead and put our 2 electrons on that first ring. Let's put our 8 electrons on this second ring. I always like to draw my E with the negative sign, which reminds us all that electrons have a negative charge. So now we have 2 on this first ring, we have 8 on the second ring, that's 10. That means we need 7 more to make it neutral in this atom. So go ahead and draw my 7 and 1 more. So 17 protons and 2 plus 8 is 10, plus another 7, that gives me 17 electrons. So now, once again, I have 17 protons, which are positive, minus 17 electrons, which is negative, gives us 0. Now, since this is a bond between a metal and a non-metal, sodium is a metal and chlorine is a non-metal, this lets me know that this is an ionic bond. And in an ionic bond, electrons either gained or lost by an atom by an element in order for them to satisfy the octet rule. So in this bond, sodium is going to give away its 1 valence electron to chlorine. Now let's see what happens. Once sodium gives that 1 valence electron away to chlorine, now sodium in its outermost shell has 8 valence electrons. 1, 2, 3, 4, 5, 6, 7, 8. And that's what sodium needs in order to be stable. So it makes perfect sense for it to give it away to chlorine. If you look over here, now chlorine had 7 valence electrons. Now it has 8 valence electrons. So it makes perfect sense for chlorine to gain an additional electron. Now let's go ahead and take a look at what happens. Sodium had 11 protons and it had 11 electrons, but now since it lost an electron, it only has 10. So I got 11 protons and 10 electrons. I have 1 more proton than electron. That's what gives it this plus 1 charge. So now sodium has a plus 1 charge because it actually has 1 more proton than electron. And if I look at chlorine, chlorine had 17 protons. It had 17 protons. It had 17 electrons. But remember, it gained an electron. So since it gained an electron, look what happens now. it's got one more negative charge. It's got one more electron than proton. So that's what gives it that -1 charge. So if we take a look at it and look at our definition, ions are elements that have a positive or negative charge as a result of gaining or losing one or more electrons. So let's go ahead and take a look at another example. Now let's practice by making an ionic bond with beryllium oxide and labeling the resulting charge of each. So we're going to be looking at beryllium right here, and we're going to go ahead and be looking at oxygen right here. First, we need to put the number of protons and neutrons in the nucleus for beryllium. So beryllium has 4 protons and it has 5 neutrons in the nucleus. Since it has 4 protons, that means we're going to we can fit 2 on this first ring, because remember on the first ring we can only fit 2. And then on this second ring, we're going to put our 2 valence electrons. So we have 4 protons, 1, 2, 3, 4 electrons. Now let's come over here to oxygen. Oxygen has 8 protons in the nucleus and 8 neutrons in the nucleus. Since it has 8 protons, it needs 8 electrons. So let's go over here and we put our first 2. And I'm not necessarily going by labeling it all the way correctly. But here we are. So now, if you notice, beryllium has 4 protons and 4 electrons. It has a neutral charge as of now. Oxygen has 8 protons and 8 electrons. It has a neutral charge. But since beryllium is a metal and oxygen is a non-metal, they're going to form an ionic bond in which one is going to give its electrons, valence electrons, to the other in order to satisfy the octet rule. So the question is it easier for oxygen to give up 6 valence electrons to beryllium, or beryllium to give up 2 valence electrons to oxygen? Well, it's much easier for beryllium to give up 2 valence electrons to oxygen, and that's exactly what's going to happen. So one is going to go here, and then one is going to go here. If you notice now, beryllium has 2 valence electrons in its outermost shell, which makes perfect sense because in this first ring there can only be 2 valence electrons. So actually beryllium is good for the octet rule. And then if you notice, oxygen can fit 8 in this one. It had 6, but oxygen just gained 2 more valence electrons. So now oxygen has 8 valence electrons in its outermost ring, so it also satisfies the octet rule. So now let's take a look. Beryllium has 4 protons. It had 4 electrons, but now it has 2 electrons. So now beryllium has that +2 charge because it lost 2 electrons. And now let's look at oxygen. Oxygen had 8 protons. Well, it still does have 8 protons. And it had 8 electrons, but now it has 10 electrons. So now 8 minus 10 gives us a -2 charge. So now if we look at it, beryllium has a +2 charge, oxygen has a -2 charge, and remember, it's a result of elements gaining or losing electrons. So there's another example of an ion being formed. Now let's take a look at our next example. I'll go ahead and label, and here we are. I'll go ahead and label what we need and what we don't need. Since we're talking about ions, we don't need our number of neutrons. That'll just confuse someone. So now let's look at the following and find the ionic charge of each. If we have 8 protons and 8 electrons, 8 minus 8 is going to give us a charge of what? 0. If we look at this one, we have 7 protons and 8 electrons, which would give us a charge of 7 minus 8 would give us a -1 charge. Why? Because I have one more electron than protons. Remember, electrons are negative, protons are positive. Then I'll look at this next one. I have 3 protons, have 1 electron. 3 minus 1 gives us a +2 charge. Then I look at our last one. I have 10 protons, we got 14 electrons, and then 10 minus 14 is actually going to give us a -4 charge. Why? Because we have 4 more electrons or 4 more negative charges than we do positive charges. Ladies and gentlemen, I hope this tutorial was helpful, and I hope you got a lot out of it. Signing off is Travis Spivey with my son Jordan Spivey, and y'all take care and have a wonderful, awesome day. Peace.